All right, this is number 3. I believe this is common in both the AB and BC exam. Okay. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is multiplied by the differential function r, where RT is measured in words per minute. Select the values of r given the table below. So this is a tabular question, okay? Very common. Approximate r prime of 1 using the average rate of change of r on the interval t is between 0 and 2. Show the work that leads to your answer. Indicate units of measure. Now it explicitly asks it, okay? So how do we find average rate of change? It's just the slope between the 2 points, okay? So r prime of 1 is approximately 2 points r1 t equals 2 and t equals 0, okay? So r of 2 minus r of 0 over 2 minus 0. So that's what, plug in, do the math, you should get 5. This is simple enough, I would calculate it, okay? So your units are, so r is already words per minute, okay? We differentiate it. It's another rate. It's the rate of change of this rate of change, okay? So it'll be words per minute per minute. You can write it like this, or you can write it as words per minute squared, something like that. I don't know, but I just wrote it like this, okay? A little easy, hopefully. Now, part B, must there be a value C for C is between 0 and 10 such that R of C is 155? Justify your answer, okay? Does this sound familiar at all? This is asking about the intermediate value theorem. Actually, from my memory, I might have forgotten, but I honestly have not seen it explicitly ask an intermediate value theorem thing on FRQ in a while, or at all, okay? So, it's usually in the multiple choice, something like that, but here it's a FRQ, all right? Maybe in the ABs it's more common, but in the BCs that I've looked at recently, I haven't seen it. Okay, so to use the intermediate value theorem, there's a prerequisite. Okay, at the bare minimum, you should state prerequisites. That's what I keep saying to my students if you worked with me before. Okay, what's the condition for intermediate value theorem? It has to be continuous on that interval. Okay, since R is differentiable, that means it's continuous. So our prerequisites met. You should at least write this. Honestly, I think they require you to do this, so I would write it, okay? I've seen it similar before in FRQs where you have to state conditions, okay? So at least state it. Or you have to. Don't at least, just state it, okay? Now, how do we use the intermediate value thing? We got to prove that within this interval, 1 point is below 155, 1 point is above 155. R of 0 is less than 155, right? It's 90. R of 10 is bigger than 155. That's 162, right? So by the intermediate value theorem, there exists at least one C in the interval C between 0 and 10, such that R of C is 155. That's it. You're done. You just have to be able to state the condition of the intermediate value theorem, state the name, probably, and then show these two right there. One's smaller, one's bigger, and then at least one, the conclusion to intermediate value theorem. Okay. Part C, use a trapezoid sum with 3 subintervals indicated by the data in the table to approximate the value of this integral. Show the work that leads to your answer, okay? So how do we find areas of trapezoids? This is how I remember. It's average of the bases times the height. The height is the delta t, okay? So in the first one, the height is 2, okay? And then we take the average of the bases. So 90 plus 100 divided by 2, okay? Next, be careful. This is a base of 6, okay? And then the next trapezoid is a base of 2, okay? So if you memorize the general formula for the trapezoid method, that's only, you probably memorize the formula for when it's equally spaced, subinterval. This one is not. So you got to be careful to not blindly use that formula, okay? So that's why I usually just do it like this instead by that formula. Honestly, I don't remember the formula. It's an easy formula to memorize, but I don't remember it. I do it manually, something like this, okay? Same with the left endpoint, right endpoint for the Riemann sums and all that, okay? I don't remember those formulas, but anyway, so this is it. And don't forget your units. It didn't say to have it here, but I would put it. It's words. When we integrate a rate of change, it's not a rate anymore, okay? So words. And don't bother simplifying. And this is not too bad to simplify, but it's risky still. So I wouldn't do it, okay? And then part D, a teacher also starts reading, at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function w, it's polynomial, where w is measured in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? Show the work that leads to your answer. So we're interested in words, right? W is words per minute, so we got to integrate, okay? Integral is net change, it's a sum, okay? So we're interested in integral from 0 to 10, wt dt. Integrate this polynomial, that's just the power rule, okay? Let's put it over here, fundamental theorem calculus from 0 to 10. Again, don't bother simplifying after you do fundamental theorem calculus, so plug in the upper bound, minus plug in the lower bound. When you plug in the lower bound, everything's 0, right? So I would just leave it like this, and then I would just put units again of words, okay? All right, that's it for this video. This question is not too bad. Again, it's in my opinion, I think it's a rare occurrence of intermediate value theorem in the FRQs. Otherwise, it's pretty straightforward, hopefully. And I want to emphasize, that when it's tedious simplification, don't do it. It's way too risky. You, at least in the most recent years, I don't know if they changed it for this year, to be honest. You don't have to simplify. Okay, and you should be able to get the full credit. Okay. Hopefully I'll see you in another video as well. Please give this video a like if you found it helpful or interesting in any way.